Hi, I'm Suhan and you are watching my sorting algorithm video. Now, in this today's topic is Lomuto's quicksort. What is quicksort and why should we learn it? As in the previous videos we discussed about merge sort and we have seen what are the advantages and what are the disadvantages. In quicksort, the worst case is n square, but here is the catch that the best case is n log n. And many of you will say that we should be using merge sort as its best and worst case is both n log n. But the n log n, when we say, is of the big O complexity, and because of it we don't take the constants in there, and in general use we see that quicksort is faster 2 to 3 times faster than merge sort, and it is a in place algorithm, so it does not take memory. It is O of 1 in space complexity. Now let's talk about quicksort. In quicksort, the general idea is that we take a point called it pivot and compare that point to every element, and then take a point in the array at which all the elements, half the array is less than the pivot and half the array is greater than the pivot, and we divide it in two parts. Now let's go through the code so that we can better understand what we are going to learn. Now in quicksort, first we compare or we pass array low and high. Here low is the lowest index of that array and high is the highest index, or the index till we want to take the array. Now at the starting the low will be 0 and the high will be the last index. Now we check that low is less than high, as we are making sure that the code does not go wrong, and if the low is greater than high then we should stop the arrays here. And then we are taking a point by calling a function called partition. In this, the partition function takes array low and high. We are assigning a pivot or the value of the pivot to be the last index or the last element, and by that we are saying that the pivot's value is the value of the last element. Now we are taking I to be the lowest element, or the to be the lowest element index 0. Now we are looping through every element from low to high so that we can compare every element with the pivot. Now here, if the pivot is greater than the element we are looping to, then it is exchanged with the I, means the lower bound. Here I represents the part from which we are, or from one step behind, we say that every element less than I is less than the pivot. As when we get an element which is less than the pivot, then we exchange I with j, or the value of I with j, and we increase it by 1. Now by increasing with it by 1, we are assigning the value of y 1 greater, means all the values which are less than I, or all the elements whose index is less than I will be less than the pivot. And then what we are doing is we are taking the array and we are assigning the high to I, then high to I, means we are swapping the values. And many of you will ask why we are swapping it, as the highest point is the pivot, and now we are assigning the value of I to the highest point, and as we know that the step at 20, this step Till this step, the value of I is greater than the pivot, as we have checked all the, or we have compared all the elements in it, and we can say that when we reach here, then I will be greater than the pivot. So we exchange the I with the pivot, and by doing it we are partitioning the points in two categories. One is the array from 0 to I, and the other is I plus 1 to the last index, or you can say we are partitioning 0 to I minus 1, then I to the last index. With that, then we are passing the quick sort by using recursion, and by it again performs the same value till it gets to the value 1, or the element or the array becomes 1. Now the general idea here is that we take an array, let's say we take an array of length 12. Then what we do is we cut that array in two pieces, like 6 and 6. In this 6, the first sixth half will be less than the pivot, and the next sixth half will be greater than or equal to the pivot. Now when doing this, we again take the 6 and cut it, and till we get 1. And here we are not assigning a new array, or we are doing all this operation in place, so there is no extra memory used. So we can say that quicksort is fast, and we can use Lomuto's quicksort to sort it quickly. But here we are comparing n times, or we are looping n times, and the recursion goes on. And Lomuto's quicksort is not efficient, as we are looping to every element from 1, and many times the worst case is near than the best case, as it became slow than merge sort. But Lomuto's quicksort is only used for education purposes, as it makes a clear path to learn how to quicksort. And the worst case of Lomuto's quicksort is n square, and it comes when all the elements are equal, or all the elements are in order. In the next video, we are going to see Lomuto's quicksort, or this quicksort, by using 3 medium form, which will make it more efficient than this code. So stay tuned for the next video. Thanks for watching. Suhan.